if we look at that in code, here is my set of strings, and I've added some stuff. Let's get rid of these for now. I think that was it. That's close enough anyway. All right, so we've got my list, and it's got the list inside of that list, right? And so we've got this third level list. I I wrote the names so that we could recognize them easily at what level they are. But I've got a function here called count strings. So the idea is that we're counting the number of strings. Now we could take all of those and put them into an array. We could do all kinds of things with them. We don't have to just count them. But the easiest thing, the simplest thing is just to count them. So I'm starting out with a count of 0 when I run this. It'll tell me what level I'm processing because I've got, when I start this, I'm going to say, give it the list and tell it what level we're at. So I'm going to tell it, we're going to count strings, AR list, and we're going to start at level 1. So we're going to process level 1, and then for each item in the list, okay, so for each item in the list, if it is a list, okay, so is instant tells me whether it's a list or not. If the item is a list, it says found a list, and then look what it does right here. Count strings. And notice that I'm adding to the count. Why? Because at the end, this count strings function returns how many it's counted so far. So every time it goes up, it's returning how many it's counted so far. So right here, this one will say, it will say 1, and this top level will have a 1 right here. And then it will count 1 at this level. So remember, every time we start that function, it starts at 0. So this one will have a 1 in it. Put a pin in that, it's still running. This one will have a 1 in it. Then we'll count these two. This one will start at 0, and we'll go 0, I say 1 and 2, right? And then it will send that, it will return the number 2 to this one. So it already has 1. So this one now will equal 3, 4, 5. It will return 5, so it'll be 1, then 6, then 7. That's how this will work. That's how it will maintain the count. So if it's a list, we do that. If not, we count. Okay, and it'll tell us. It'll tell us the name of the item. It'll tell us the level and the count. So I've got massive numbers of print statements in here communicating each phase of this so we can see. Now, if I removed all of those print statements, I want you to see here, about half of this code is print statements. Most of this code is just doing, about half of it is doing the work and about half of it is observing what's going on. So if I took out all the print statements, this is very short code to be able to process any list of any shape. But let's run this. Okay, and let's see what we got. Okay, so processing level 1, we count Adam. Level 1 has 1, right? Then we find a list. This is the list we find in that second position. So we're right here. We found a list. Processing level 2. Level 2 has 1 because we counted Bob. Next, we find a list. So we're processing level 3 down here. Counting Chet, counting Cat. Now we're returning 2 to level 2. So now level 2 has 3 total. Okay, so when we return here, level 2 has counted Bob and Chet and Cat. Then we count Barb and Bert, 4 and 5, and then we return 5 to level 1. Level 1 now has 6 total. So it has Adam, Bob, Chet, Cat, Barb, and Bert. That's 6. We're returning 6. Now we count Alex, Level 1 has 7 total. Then we find B and Bill, that list. We add 2. It returns those 2 back to level 1, which has 9. And then we count Ann, and we have 10. So it's a bit of a brain bender, but watch this. Like I said, we can add another list inside here. Okay, for a 4th level. And if I run that, it will find Dave and Darla right here, level 4, counts those and returns it to level 3. It does not matter what the shape is of the list that I give this. It will process any list of any size, any number of levels, does not matter. Does not matter how many times it goes back down to a lower level, how many lists are inside of lists. It just will crank right through it. So this is something I technically could do without recursion, but only if I knew how many levels there were. Only if I knew how many levels there were. With recursion, I don't even have to know that. All I have to know is that it's a tree structure, and I can comprehend that tree structure using recursion. So recursion is the best solution for some things.